Okay, so we're going to do a deeper dive into standard deviation for a bit, and I'm going to talk about what standard deviation is and what it means. It's one of the more complicated statistical figures to wrap your brain around. A reminder that standard deviation, the value of standard deviation is different for when you have population or a sample set. So a reminder just quickly that a population standard deviation is when you have the entire group that you want to draw conclusions from, and sample means that you only have a portion of the group that you want to draw conclusions from. So for example, if you're looking at, how many people at a certain doctor's office has insurance. So if you're surveying every patient that goes into the specific doctor's office in general, just every single patient that this doctor has, then that would be population. But if you decide to just on a specific day ask the patients that have appointments for that day, if they have insurance at this doctor's office, then that would be sample, because you're not asking every single one of this doctor's patients. You are only asking the people that had appointments for that day. So just keep that in mind. Remember, population and sample for the standard deviation, it matters what group we're working with. Now, if you have a higher standard deviation, this means that on average, the data points are further from the mean. So for example, maybe we have this red distribution here, and the mean, remember, is where the line of symmetry is drawn. Oops. The mean is where that line of symmetry is drawn. So if my line of symmetry is right here, well, if we notice, these data values are going to be closer to that line of symmetry because the Bell distribution is a lot skinnier. So my standard deviation for this one is 0.5. Now for the blue the blue bell curve, my mean is here because it's where the line of symmetry would be. And for this one, we notice that this blue bell shape is a little bit wider than my red bell shape was, so we can expect it to have a higher deviation, standard deviation, which it does. And then lastly, my green bell-shaped curve, we can even expect this to have a higher standard deviation because it looks like on average the data values are further away from the mean, and so it does have a higher standard deviation. So what standard deviation is it is when your data values on average how far they are away from the mean. So if your data values are further away from the mean, you can predict to have a higher standard deviation. If your data values are closer to the mean, then you can predict to have a lower standard deviation. Standard deviation is the amount of variability within your data points. So if you have your data points very closely clustered together, then your data set will have a low standard deviation. As opposed to if your data values are far away from one another, then your data set will have a high standard deviation. Now, the closer that the standard deviation is to 0, the closer the data points are to the mean. So the standard deviation is basically just telling you how much variability there is in your data set. All right. So standard deviation has nothing to do with whether your data is symmetrical or not. It doesn't have to do with skewness. Skewness is affected by the mean and the median, so the measures of central tendency. But I will tell you that if you have skewed data, you could have a higher standard deviation because skewed data would mean that you could potentially have outliers. And I will talk about outliers in the next lesson. But keep in mind that if we know that a data set has a certain standard deviation, that does not tell us necessarily how symmetrical. Because for example, in all 3 of these bell curves, all of these look pretty symmetrical. and they all have different standard deviations. All right, so number one, which of the following data sets would have a standard deviation closest to 0? We're doing this without our calculator, so we're not actually going to be finding the standard deviation of all of these data sets. We're just going to look at the data sets and determine which one looks more varied. Well, if I look at letter A, actually these numbers are kind of close together and all kind of evenly spread out amongst the mean. All right, and letter B, same thing. These are very close together. All right, now letter C, this is the median of the data set, so not the mean, but if we were to find the mean, it would possibly be closer to the median here. And notice that these data points on the left and the right are pretty far away from that value of 10 here. And again, standard deviation is when you have points far away from your mean, but just kind of looking at this data set, you can see that it's kind of pretty varied here. There's a lot of points that are far away from your mean. And then letter D, same with letter D. Letter D looks pretty varied. However, what makes letter D not have as high of a standard deviation as letter C, because letter C is going to be our answer here, is we do have 3 points that are the same exact value, so we have a pretty high mode here. And so the other points are not going to be too far off from your mean. These 3 points are not going to be too far off from your mean, while the other 3 might be. But in letter C, we have quite a few points that are far off from the mean. So letter C would have the higher standard deviation. All right, so number 2, we want to find the mean, the interquartile range, and the standard deviation. However, we are given a word problem, so we're not going to always just find population and sample. We need to determine which one we're going to find. A farm is studying the weight of baby chicks after 1 week of growth. They find the weight in ounces of 20 chicks. All right, so for this, the whole farm is being studied here. All the baby chicks are being studied here, so this is population. So we want to find the population mean and standard deviation that's given here. So the mean, I'm going to add all these up. I'm just going to do that in my calculator. I don't need to write it down. In fact, I will write it down. So we have 2 1s. So I'm going to do 2 times 1 plus, I have 1, 2, 3 2s. So 3 times 2 plus 1, 2, 3, 4, 5 3s plus 1, 2, 3, 4 4s. I'm sorry, I'm going into the interquartile range right now. 1, 2, 3, 3 5s, 2 6s, and 1. And then I'm going to divide all of that by 1, 2, there's 20 chicks, so I don't even have to count. Sorry, 20. So 2 times a 1 plus a 3 times a 2 plus a 5 times a 3 plus a 4 times a 4 plus a 3 times a 5 plus a 2 times a 6 plus an 8 is a 74. And again, all over 20. And we're going to round to the nearest tenth. And I have 3.7 as my mean. Since this is population, then the mean is with that weird U, if you want to use this symbol to describe it. So my mean is 3.7. Now my interquartile range, I do need to arrange this in order. So remember, I had 2 1s, 3 2s, 5 3s, 4 4s, 3 5s, 2 6s, and 1 8. So starting from the outer ones and working my way in. I wind up with my median being in between 3 and 4, so my median falls here. And now doing first quartile. I wind up with that being in between 2 and 3. So my quartile 1 is 2.5. And my quartile 3 is in between 5 and 5, so my quartile 3 is 5. So my IQR is going to be 5 minus 2.5, which equals 2.5. All right, now we're going to do the standard deviation. All right, in standard deviation, we have done this before. I'm going to do it again with you. So now we take my data value of 1, and I'm going to subtract that from my mean, which was 3.7, and then I square that number. But since I had 2 ones, I'm going to multiply that by 2. My next data point was 2. I'm going to do the same thing, subtract from 3.7 and square it. But I had 3 2s, so I'm going to multiply that by 3. My next data point was 3. So same thing. But I had 5 3s, so I'm going to put that in there. And sorry, I'm going to need to move down. My next data point was 4, or move over. And I had 4 4s. My next data point was 5. And I had 3 5s. My next data point was 6. And I had 2 6s. And my next data point was 8. And I just had one of those. Okay, so a 1 minus a 3.7 squared comes out to be a 7.29, or 7.29, yeah. All right, a 2 minus a 3.7 squared comes out to be a 2.89, and I had 3 of those. A 3 minus a 3.7 squared is a 0.49, and I had 5 of those. 4 minus 3.7 squared, that comes out to be a 0.09, and I had 4 of those. 5 minus 3.7 squared is a 1.69, and I had 3 of those. 6 minus 3.7 squared is a 5.29, and I had 2 of those. And then finally the last one, 8 minus 3.7 squared is 18.49. So I'm going to add all this up. And I get a sum of 60.18. And then since it's population, I'm going to divide by the actual number of data points there are, which is 20. And I'm going to take the square root of that. So 60.18 divided by a 20 is a 3.009. And the square root of that is a 1.7. But not only do we need to find the population standard deviation, and not only do we have to do that, we need to give an interpretation of what standard deviation means. So what this means, and I'm going to type it out, is on average, any given weight will be 1.7 ounces away from the mean. All right, And that is standard deviation, and we'll do more with that in some upcoming lessons as well.